Hello and welcome. In this video, I'm going to complete a series of tasks for MPLS on OcNOS devices. The previous configuration that I have, I'm going to speak about it a little bit, and after that I'm going to explain the tasks that I'm going to do, because what I am doing is based on a previous configuration, which I'm not going to do it again. So what we have here is multiple companies, specifically 4 companies. Each one of them have 2 branches, and they are receiving a connectivity service from OE Net Solution service provider. OE Net Solutions provides MPLS services in layer 2 and layer 3, of course, and it supports multiple technologies which we are going to cover in different videos. But what we are interested in right now is the company which is called Globetrotter. It has 2 different branches in different parts of the country, and it receives the connectivity service from OE Net Solutions. Now, Globetrotter in a previous configuration was connected to OE Net Solutions using BGP. So what we did was we configured router 1 and router 5 as PEs, provider edge routers, router 2, 3, and 4 as P routers, which are BGP free core of my network. What I did was I created a VRF on router 1 and router 5. I assigned this interface to the VRF, and then I created a BGP neighborship with router 12 and on the other side with router 13 using router 1 and router 5. And I did 2 different things. In the beginning, I configured Globetrotter, the first branch, as BGP Autonomous System 650, the other one as 651. And later I changed the configuration and I made sure that both of them are using the same autonomous system 650, which gave us a little challenge on loop prevention, which I configured allow AS in on the branches or AS override on the autonomous service provider network to just prevent this kind of a loop to happen in my network. Of course, not prevent, just to give it a kind of a temporary solution to make sure that we are receiving the prefixes from the other side. Now, the task says that I should change the configuration on the network. I should provide MPLS L3 VPN service to this customer Globetrotter, which I have done it previously, of course, but I'm going to make sure that this time, instead of BGP, my customer edge router, which is R12 and R13, they are using ospf. And in the end, of course, it says that any route that are received should be as inter area. And for this, I need to just make sure that both of them are using the same domain ID, or I have not configured any domain ID. Now, on OcNOS devices, I'm not going to configure any domain ID because domain IDs go under VRF, and I'm not going to configure VRF on these branches. But I'm going to show you what I'm going to do. I just want to make sure that both of them are using the same process ID for ospf. Later, we are going to have some verification commands just to make sure that everything is working just fine. Okay, let's start the configuration. The first thing that I'm going to do is to go to router 12 and 13 and remove BGP configuration, replace them with ospf. So on R12, I'm going to say show IP protocol. You can see that BGP 650 is running on here. Going to configuration mode, and I'm going to say no router BGP 650, and I'm going to replace it with router ospf 1. This one, of course, is the process ID, and it is locally significant. So whatever number that you're using, that's okay. I just want to make sure that both sides are using the same process ID. Later, I'm going to tell you why. Router ID is going to be configured here, and I'm just configuring this manually because I just want to make sure that the exact IP address form that I want to use is going to be replaced here, because my loopback interface might have multiple IP addresses set on that, and I don't want just to select a random one which is going to be the highest number for the router ID. Okay, the network is going to be 0000 /0, and I'm going to say it is going to be under area 0, and that's it. The whole configuration that I'm going to do right now. So I just commit the configuration. Okay, so for now, if I just say show run router ospf, you see that? And let's go to router 13 and do the same thing. On router 13, I'm going to log in. And show IP protocols says that BGP 651 is configured here. So I'm going to remove this. No router BGP 651. Router ospf1. Router ospf1. Router ID is going to be 13, 13, 13, 13. And I'm going to have a network of 0000/0 under area 0. So I'm going to say commit the configuration. Okay, so what we have here, it says that you should clear the IP ospf process. I can do it, no problem. Okay, that's it. But there is nothing to commit, of course. Now the next thing that I want to do is to go to my provider edges, which is router 1 and router 5. And on this specific interface, which is under VRF, I'm going to configure ospf. First of all, I want to show you the configuration in case you are doing everything afresh, so that you can just kind of catch up with me. And after that, we are going to configure ospf. So on router 1, if I just say, first of all, I need to log in, of course. I'm going to say, come on. No, that's okay. I'm going to say show run VRF. The name of the VRF, of course, is called Globetrotter. So this is the VRF that I have configured before. A very simple value for route distinguisher. The same value, which of course it is not mandatory. I have used for route target for both import and export, and I have done the same thing on the other PE, of course, so that I have this VRF configured on them. So if I just say show run interface EAT6, which is the interface connected to Globetrotter, you can see that this interface is under VRF forwarding GT, which is the Globetrotter. And then I'm going to show you the running configuration of router BGP. Now, show run router BGP. You can see that under here, I don't have any IPv4 address family for PEs. The only address family which PEs are using is VPN v4 unicast. For the Globetrotter VRF, of course, I'm going to create address family IPv4 VRF GT, and after that, I can just configure everything, for example, the neighbor definition, and in case I want to advertise anything from the network which is connected to that, let's say, for example, this network, I just use redistribute connected. But right now I'm going to remove this because this is no longer necessary. What I'm going to do is to configure ospf now, and that ospf, of course, needs to run under a VRF because I am connecting to this network using a VRF enabled interface. So let's go to configuration mode. In configuration mode, what I'm going to say is router ospf, let's say 1. And then after that, you can see that there is a VRF name that I can associate this instance with that. I can just say GT, and after that, hit enter. This GT makes sure that this ospf process is going to work under Globetrotter VRF. I'm going to say router ID is going to be 1111. Then I'm going to say network. And if I say 0000/0 and put it under area 0, it is going to contain every interface inside ospf process. But because we are just talking about interfaces under Globetrotter, there is only one interface included, which is going to be Ethernet 6. So I'm just safely using this network. But in case you have multiple networks under this VRF and you want to be specific about that, you can just type in the actual addresses that you really want to include in ospf process. Okay, so that's it, and let's commit this first part. Commit with 2 M's only and an I, of course. Okay, now that I have done this, I'm going to say do show IP ospf neighbor, and after some time, of course, I should see that I am in adjacency with router 12, and you can see that. Okay, great, but what about the rest of the procedure? Okay, I'm going to do that in a second, but before that, let's do the same thing on the other side. On router 13, I configured ospf, and now router 5, which is my provider edge on the right, needs to have the same configuration. So let's do this. I'm going to go to here, go to configuration mode, and I'm going to say router ospf1. Router ID is going to be 5555. And let's say that no, abort transaction. I'm going to say router ospf1 GT, because I'm going to configure this under Globetrotter VRF, and this is on provider edge. On customer edge doesn't have any idea about what VRF is and what is it doing. So I'm going to configure router ID as this, and then I'm going to say network is going to be 0000/0 under area 0. So I'm going to commit this, and if I say do show IP ospf neighbor, after some time I should see that I am in adjacency with 13, 13, 13, 13. Great. Now what I'm going to do is to go under BGP process. And on BGP process, I need to make sure that I am redistributing prefixes from VRF into the customer VRF here, from this neighbor into the customer VRF, which is going to go to the other side, and from there I need to redistribute it back to ospf under VRF. So what I'm going to do is from ospf I'm going to redistribute into BGP for that specific VRF. That's going to be taken to the other side using VPN v4, and on the other side what I'm going to do is to redistribute it back from BGP into ospf, and ospf is going to take it to here. This is going to be a two-way process, so I'm going to do this like this, and this is going to happen in my network. I'm going to do this, and in the end, of course, we are going to have a review of the configuration. So let's go to router 1 first. On router 1, I'm going to say show run router BGP. And what I'm going to do is to go to router BGP 100. Under this specific address family, which is for Globetrotter, I'm going to remove this adjacency because this is no longer necessary. Now, what is necessary here, of course, is to redistribute ospf routes. If I say redistribute ospf, and after that it says the process ID, that's it, nothing more than that, what is going to happen? It is going to redistribute any ospf prefixes that come from an ospf process which is under Globetrotter. Why? Because we are talking about this address family under Globetrotter. So that's going to be what is happening. Now, I need to redistribute BGP into ospf as well. So what I'm going to do is to go back to router ospf. So I'm going to say router ospf1 GT, and then I'm going to say redistribute BGP, and the BGP is not going to have necessarily the autonomous system number. It doesn't have to have anything, just say redistribute BGP, and that's it. And I'm going to say commit. So what did I do? ospf is redistributing BGP, and because ospf is under Globetrotter, so it just redistributes the address family GT. BGP is redistributing ospf. Because we are doing this under Globetrotter VRF, it is just redistributing ospf under Globetrotter. That's all that we are doing here. The same thing should happen on router 5, of course. I go to router 5, and right now I am under ospf, so I'm going to say redistribute BGP. That's all. And then I'm going to go to router BGP 100, and let me show the running configuration of router BGP so that I can see this clearly. I need to go under address family IPv4 VRF GT. I don't need this adjacency, so I'm going to remove it, and I'm going to say redistribute ospf1 and hit enter, and then say commit. Okay, so the two-way redistribution is done. Now what I need to see is all the prefixes from router 12 on router 13, or let's say from branch 1 to on branch 2, and from branch 2 on branch 1. So if I just go to router 12 and say show IP route, now you can see that I am receiving this 13, 13, 13, 13 from the other side. And what I am receiving here is an inter-area network, exactly as requested by the task. What is this E2 here? Let's go back and visit the BGP configuration. So on router 5, for example, what you see here is redistribute connected network. So that is the reason that I am seeing some of the external routes in here. Do I want to remove it? No, actually I don't. But if you want to, you can just remove this, because with saying ospf 0000, this interface is going to be under ospf process as well, and it will be advertised as inter-area. So let me just see here. It says that all the customer edge devices should receive p-land route as inter-area. Okay, the task mandates me to remove this line. So let's remove this line. So right now, I'm going to say no redistribute connected here and commit it. And the same thing should go under router 1. So I'm going to say router BGP 100. And under that, IP address family IPv4. I'm going to say no redistribute connected and commit the configuration. With this, if I go back to routers and check this, those routes are going to be advertised as inter-area routes for us. Okay, so on router 12, what I'm going to do is to say do show IP ospf. With this show IP ospf, you can see a list of a lot of different things are being advertised here, are being visible. The ospf1 has this ID here. What I am interested in is going to be the domain ID, whether I have set domain ID or not. We didn't set it, of course. Like I said, if I just configure domain ID, then it will say that it should go under a specific VRF. So if I just say show IP ospf, and I'm going to say include domain, or domain with capital D, nothing is set. And because domain ID could be set under VRF, I can just set it on R1 and R5. So let's do this and see the effect here. I'm going to go to router 1. I'm going to say router ospf1 GT. And then I'm going to say domain ID, let's say 1111. And configure this and commit this. Okay, it says that clear the IP ospf process. I'm going to do that. You should do this on VRFs. And just to show you that this is not possible under non-VRF configuration, I go to router 12, which is here, and there is no VRF configured. So I'm going to say domain ID, let's say 12.12.12.12, and then I say commit. You can see that it is going to give me this error that this is not possible. Domain ID cannot be configured on non-VRF instances. So I'm going to say abort transaction. Okay, let's go back to router 1. I configured this domain ID 1111, and I just committed the configuration, and I cleared the IP ospf process. The same thing should happen on the other side, router 5. So I'm going to say router ospf1 gt, and I'm going to say domain ID is going to be 5555. So domain IDs are different here. Be careful about that. So I'm going to say commit, and then I'm going to say clear IP ospf process. Now let's go to router 12 and 13 and see the effect on that. Do show IP route. This time I am receiving the prefixes as external prefixes, not internal, not inter-area prefixes. And that's going to take some time, of course, to receive all the prefixes, and now we have received all the prefixes from the other side. So in case you want to receive them as external, all you need to do is to ask the service provider to change the domain ID for different routers, and that's going to change the fact for you. So why do we need to have inter-area or external routes in case of ospf? This could be good thing just to make sure that your traffic engineering is going to work as expected. Okay, one last thing. Do ping 13, 13, 13, 13, and the ping goes through without any problem. And if I just source it from 12, 12, 12, 12, again the ping goes through without any problem. So we have the reachability implemented in this task. With this, the task is completed. We just examine different things, how we can make sure that we have inter-area or external routes. This is of course done in extra, and how we can configure ospf on PECEs, and of course everything is done. So I hope this has been informative for you, and see you in next videos.